You're not really sure what ATP is quite yet, and you want to know what ATP is before we get into what this whole ATP hydrolysis reaction is. Okay, so let's do that real quick. So let's say I throw this pen. How was I able to do that? Well, I called on my skeletal muscle to contract so I could throw the pen. How did that contraction happen? Well, that contraction happened because I was able to use stored energy and break that stored energy to allow that muscle contraction in my skeletal muscle to happen. What was this stored energy? How did we use the stored energy in the cell? Well, that stored energy in the cell is referred to as ATP, also known as adenosine triphosphate. That's composed of an adenine, a ribose, and 3 phosphate groups. The stored energy that's broken in this ATP hydrolysis that we're going to get to is stored between the 2nd phosphate group and the 3rd phosphate group. That 2nd phosphate group can also be referred to as the beta phosphate group, and the 3rd phosphate group can also be referred to as the gamma phosphate group. It's between these 2 phosphate groups where the energy is stored, and where it will eventually be broken in this ATP hydrolysis reaction. Why is there energy being released here at all? Why is ATP so energy dense? Well, if you look at the structure of ATP, you'll see that there are 4 negatively charged oxygens all in close relation to one another. And what do like charges do to one another? Well, like repels like. And so ATP is going to be considered to be a relatively unstable molecule, relatively unstable compound. If we draw out a graph where delta G, or Gibbs free energy, is on the y-axis, and on the x-axis is the reaction progress of this hydrolysis reaction, what's going to happen is you're going to start at a higher energy because you're at ATP, and once that ATP is broken into ADP, which is more stable, it's going to be at lower energy. What does this mean? Well, it means this is an exergonic reaction. You're releasing energy. That literally means that once we're going from the more unstable ATP to the more stable ADP, we're releasing energy. Cool. How does it happen? How does ATP get broken down into ADP and its other byproducts? So let's see the ATP hydrolysis mechanism. You're going to be in a cell, so you're going to have aqueous solution. You're going to have water surrounding you. So the waters are going to react with one another. You're going to have the electrons on the oxygen that are going to interact with the hydrogen. It's going to create a hydronium ion. You're going to have a hydroxide anion where it's going to do a backside nucleophilic attack on the gamma phosphoryl group at the phosphate. And this phosphate will no longer be able to hold the bond with the beta phosphate group. And so it's going to break off. And in breaking that bond with the phosphate group, it leads to the final products of this reaction. And of course, the released energy that's used for the skeletal muscle contraction. So now you know how this process happens, how we take this stored energy in ATP, in what's considered to be the universal currency of energy in our cells, and we break that down for energy. So hopefully now that you know this, now you've seen this illustration, you're able to visualize this at a kind of micro level. And I think that's one of the most beautiful things in life itself, is we're able to go from the macro to the micro, and going up and down on that ladder, from zoning in on a specific thing and going full micro, then going macro and seeing things from afar, is what makes life so beautiful. And it's that kind of going up and down that ladder of super focused on one specific thing, and really looking at the micro, whoa, and then going all the way back and saying, wow, let's look at the macro here. Let's see how the person throws, and then going close and saying, hey, let's see how that happens at a physiological level. Let's see what's the chemistry of what's going on there. I think that's beautiful, and I hope you enjoyed this video. I hope it helped you in whatever you're doing. Take care. Peace.